Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott. And if you'd like to call us up and ask us one of your math problems, give us a call here in Bakersfield, 636-4357. If you're in San Luis Obispo, toll free, 866-636-6284. You can even email us your question at dothemath@kern.org. You can watch the show online if you're not already watching on your cable broadcast at dothemathonline.net and all over social media. You can get a hold of us by Facebook, Instagram, Twitter, and YouTube. Give us a call.
All right. Now, you said that they can call with one of their math problems.
Right.
What if it's a really long and detailed and difficult math problem?
Then maybe we can get them their own show. How about
There
that?
we go. You know what? But we'll still help them out. And if you have another problem, we can always work with that one also.
Right.
But you need to give us a call first. That's the first thing you need to do. Today, big day.
Yep.
Opening day of the fair.
That's right. I've already been there, actually.
You have?
I was there
How,
early.
It's opening day.
That's right, because my kids have pigs going in the fair. So I went to see where we're going. The animals are starting to show up. The people are starting to show up. It already smells like corn dogs. It's a good place to be this time of year. And it's not 105 degrees.
It's funny because yesterday in the cafeteria they were serving corn dogs. It's like, getting ready for the fair,
yeah,
huh?
That's right. They can hear it coming.
Anyway, today is the first day of the fair, and like last week, today also we will be giving away tickets to the Kern County Fair to all of the students that are able to go on air today. So if you give us a call and we do one of the math problems on air, you will be going to the Kern County Fair for free. If you're phoning in from San Luis Obispo County and for whatever reason you're coming over to Kern County, you want to go to the fair, let us know. We'll give you a ticket to the fair. But if you're staying in San Luis Obispo County, we can give you some free ice cream courtesy of Doc Bernstein's Ice Cream Lab.
Pretty good deal. Maybe we'll go to San Luis Obispo at some point and get some of that.
You know, I'll bring you over sometime because we go over there every year and we film over there. And we stop by Doc's and see him every year. Do you have a favorite flavor?
Mint chocolate chip, definitely my favorite ice cream.
All right, you know what? They have that over there,
Big
and I'm
fan.
sure they can make something up for you too
All right.
also. Hey, you know what? Guest in studio, and we have some phone calls to get to, but first, let's take a look at today's Math in the News. So this morning, somebody said, hey, did you hear about the nails? And I'm thinking nails like a hammer and nails.
Right.
Right, like some new nail come out or something.
Sure.
So when you think of nails, do you think of that or do you think of
I definitely think of
fingernails?
the hardware part. Like all the prices went up because of the hurricanes and they're fixing a bunch of stuff and anyway, we went way down that track. But we're looking at some different nails.
Could be, yeah. So let's go ahead and take a look at the, and we can see that there are a bunch of different types of nails on there. So, and I am sure there is a lot of money in nail art.
Right.
Okay. So we can see where there's some, you know, I guess you would say kind of ordinary or plain, you know, just like two colors on there. Festive.
Yeah.
You know, and then some where I would imagine it's going to cost a little more based on the type of nail polish and things like that that you're doing. So the reason I bring this up, and we can go ahead and take a look at the photo we have under the camera. This is Miss Williams. And Miss Williams has taken 20 years to achieve the nails on her hand that she has right there. She lives in Texas.
Yeah.
Big fan of Texas. Everything's
Right.
bigger in Texas. Well,
Everything,
big
that's
fingernails
right. Even
are in
fingernails.
Texas too. And 18 feet, 10.9 inches, the cumulative length of those nails. Now, it takes her, now, she is a nail technician. So she does this
And
stuff.
she can still work with those nails.
Over 20 hours to paint her nails.
Wow.
Okay, 20 hours to paint her nails. 2 bottles of nail polish. All right, only does it once a month, uses acrylic. I guess that's the superior one if you're going to do it once a month with nails like that. She washes them 3 times a day, just the nails, not your hands, just the nails, and rests them on a pillow. Okay?
Special nail pillow.
I kid you not.
All right.
Okay?
You can't make that stuff up.
I clean them with a brush at the sink, she says. I use disinfectant or bleach. And sometimes if I'm eating popcorn, I would just stab it, right? She uses a spoon and then uses a pencil or one of her knuckles to use her cell phone or computer. And get this, this is the best thing about this. She doesn't have to do any chores around the house because she can't do anything.
Right.
Right? So what she does is she has somebody else do the chores around the house. So I figured, all right, let's apply some more math to this. So here we are with converting measurements. So we'll take a look at the screen once again. Customary units of length. So we have 1 foot is 12 inches. We all know that. 1 yard has 3 feet. So if we take a look at the 18 feet and 10.9 inches of nails that she has, 227 inches approximately, or 6.3 yards of nails. Simply amazing, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available on Tuesdays and Wednesdays between 3:30 and 5:30. And in studio with us right now, we have a young lady from Stockdale. And why don't you let everybody know your name and what grade you're in?
I'm Rhea Kelsey, and I'm in 4th grade.
All right. And Rhea, do you have nails anywhere near that long?
No.
Let's see.
No.
Come on.
No, see, I mean, all our nails, I mean, are pretty, like, I would say, normal length, right? Do you think you would ever want to do anything like that?
No.
Do you have any idea why she did that?
No.
To get into the Guinness Book of World Records, and she got in, which is why the story
Is
is
she the
out
winner?
there. So
She's
she
the
is now
longest.
in the 2018 Guinness Book of World Records for having almost 19 feet at present of cumulative nail length.
Yeah.
That is simply amazing. But anyway, how's 4th grade?
Good.
Do you like going to school for a longer day now?
Yeah.
You like that? Mm-hmm. Guess what's going to happen when you go to 7th grade? You're going to go to school even longer. Are you good for that?
Yeah.
What about when you go to high school and you have to go to school even longer than that? Are you good with that?
Yeah.
All right. And what about after that when you go to college or work and you have to go even longer than that? Are you good with that?
Yeah.
All right. So you're good with basically anything that goes on, right? Mm-hmm. All right. Well, how about we do this? How about we put you to work? Are you ready? All right. Head on over to the board with Scott. We are going to take a look at your book. And we're going to do one of these problems, and we're going to do number 2. So what I'd like you to do is maybe at the very top of the board, write down these numbers. All right? We have 5, 3, yep.
There you go.
4, 9, 8, and 1. Now on here, the book says, Nancy wrote the greatest number that can be made using each of these exactly once. So why don't we do that first? So what is the largest number you can write using each of those once? And while you're doing it, explain to us what you're doing and why you're putting numbers in a certain place.
Okay. I put 9 here because it's the greatest number.
Good idea.
And then I do an 8 because it's the second biggest one.
Yeah.
Then I do a 5. And then a 4. Then a 3. Then a 1.
Awesome. Okay. You think we could put a comma in there so we could figure out what this number is? Where's that comma go?
Right here.
There you go. Do you know what that number is? Can you tell us what it is in words?
885,431.
Good job. And the first number's a 9 there, so 985,000. Now, are you sure that's the biggest possible number that we can make with those numbers, those digits? I like how you went from biggest to smallest. That was a good idea. So if you switch the 1 and the 3 around, that wouldn't be a bigger number?
No.
No, it wouldn't. You're right. I like that one. What else you got for us, Mike? What
All
other
right,
challenge
you know
do we
what?
have?
Let's take a look at one more right here. We've got a couple of options on number 1.
Okay.
So let's take a look at this. And it says, select a number that will make a true comparison. Mark all that apply. So why don't you go ahead and erase that, and there's a way, Scott, there you go, see that?
I'm getting better.
You don't have to do that little erase and get rid of it all at once, all right? The number is 703,209. So 703,000.
I'm going to stick a 0 in there for you. Woo! 703.
209.
Well done.
And Scott, how about if on the left-hand side you make a column of these numbers?
Okay.
All right. The first one, 702,309. The next one, 703,029. The next one, 703,209. The next one, 703,290. We have 2 more.
I got you writing too big there. All right.
That's okay. You can squeeze these in somewhere. 730,029. And you could probably squeeze one between the first and second one, I would imagine.
I think you're right.
730,209. Now,
Right.
we have Ria's number, 703,209. Next to that, we have a greater than symbol. So at the end of the 9, put a greater than symbol.
Aha, so you have a sign there, right? And this sign's going to say that the number over here is bigger, but what Mike wanted is a greater than sign. So is it true, Mike, that we want this number to be bigger than the new one? Is that right?
Correct.
All right, so can you erase that real quick and see if we can go the other direction? There you go. We'll make it go the other way. So, just to make sure we're clear, right? We want to choose some numbers that are smaller than this one so that this one is going to be bigger than the ones we choose. Does that make sense? Okay, so we need to look for some numbers that are smaller. And is it true that the instructions say we want to choose all the numbers that are possible
Yes.
to get smaller?
All
Okay.
that apply.
Gotcha. So what do you think? Should we just look at all of them, or should we go one by one? What do you think?
We should go by one.
Yeah, I think so too. All right, so what about the very first one that we have on the top here? This number is 702,309. Is that bigger than what you have? It's got the same numbers in it, got the same digits.
But it's not bigger.
It's not bigger. How come? What's wrong?
Because right here in the thousands place, there's a 3, and that one, there's a 2.
Yeah, that's right. So I'm going to underline that one for you real quick. So this part was the key to this one, right? And it's smaller, so that one would work, right?
Okay.
That one would work on our spot. So over here, can you make a list of the ones that work? Why don't you go ahead and write that number that we have up here, 702,309. Yeah. 309. That's one of ours. And so we have used that one. What about the next one? Again, we're looking for numbers that are smaller than yours, right? So the next one, I'm sorry that I have kind of bad handwriting here, but that one says 730,000. What do you think? Bigger or smaller than the one you have?
It's bigger
It's bigger. How'd you know that?
because right here, there's a 3 in the 10,000s digit.
3 in the 10,000s. That was the giveaway, huh? So that one, not going to happen. Next one. What do we got?
3.
703,000. So we have thousands, same. 10,000, same. So the criteria that you used up here, so far, were the same. What about the next one? The next place is the hundreds place, right? And now I have a 0 and you have
A 2.
a 2. Is your number bigger than this one?
Yes.
It is. It's going to work. So let's go ahead and make that part of your list also. Well done. So we have that one. Nice job. Next one, 703,000. So far we're the same. Then we have 209. Have you ever seen this number before?
Yes.
Where?
Right here.
That's the same number. Exactly. So is your number bigger than this number?
No.
I think I'd have to agree with you. Not going to happen. Doesn't work. They're exactly, what
The
else would you say?
same.
That is the same, yeah. So if you had an equal sign there, it would work, but not a greater than sign. Next, 703,000, which is what you have, 290. And last time we looked at the hundreds place, but you have a 2 also. So we got to keep going, right? What's the next place?
The 10s.
Yeah, the tens place. And now I have a 9, and you have a 0. Is yours bigger than mine?
No.
Nope, not going to happen. So this doesn't work either. We got one more option, right? Do you think, notice every single number we have on here has the same digits, right? 7 and a 2 and a 3 and a 9 and a couple of zeros. They're just all mixed up. So can you tell me what this number is? Say this number out loud. What are the words that go along with it?
730,024.
Yep, that's it. And it's because of my bad handwriting, but it's a 9 there. But you're right, it is 730,000. So is 730,000 going to be smaller than yours?
No.
Not going to happen. So looks like we have 4 strikes, and we have 2 of them that worked. So 2 out of the 6 worked out okay. But I think if we were playing baseball, Mike, we'd be struck out by now. We struck out with 4 of them.
All right, there you go. Well, nicely done. And Rhea, because you're a guest on today's show, you'll be receiving a free meal courtesy of Liddy and our friends over at Johnny Rockets. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. Just as a reminder, today is the final day, September 20th, the first day of the fair, but it's the last day on Do the Math where you can actually win a ticket to the Kern County Fair. And right now we're going to go to the phones. And Riley, how are you?
Good.
And Riley, you are a 4th grade student as well, correct?
Yes.
Okay. So Rhea, usually I have you come over here and you stand by me and we just watch Scott do the problem. But I think the problem that Riley is phoning in with is one of the problems in your book. So I want you to help Scott figure this out and explain it. All right? So Riley, as soon as you're ready, go ahead and read the problem. And Scott, if we need to, I've got it under the camera out of Rhea's book.
Sounds
all right?
good.
Riley, let's hear it.
The total season attendance for a college's team's home games, rounded to the nearest 10,000, was 270,000. For numbers 7A through 7D, select yes or no to tell whether the number could be the exact attendance.
So if you want to, I can give you these numbers and you can write them down.
Sure.
All right, so the first number is 265,888.
Okay.
The next number is 260,987.
Okay.
The next one, 274,499. Final one, 206,636. Now, next to each of those, there is a yes and no.
Okay.
So I
we
guess
know.
you can just put a Y and an N over there next to each of those. And we're going to reverse roles. Scott, you're going to stand there. And
can do that.
Rhea, you're going to go through this problem with Riley and figure out how we need to answer this accordingly, all right? So the question says, select yes or no to tell whether the number could be the exact attendance if you were rounding this number, okay?
Which place value are we rounding to again?
Well, let's see. It says to the nearest 10,000.
Gotcha. So let's look at the first number at the top and just make sure you know where the 10,000s is, and then I promise I'll be quiet and let you do it. Which place is the 10,000s up at the top number there?
This one.
Gotcha. Okay, go ahead and underline that one real quick. Okay, so how would you go about doing this one?
I would go next door. If this is 5 or more, I change this, add one more, and if it's 4 and less, I keep it the same.
That's exactly right. You got it. And so let's be clear about what the question asks, right? It says one of these, or maybe more than one, could be the actual number. And if you rounded it to the nearest 10,000, you would get that answer. Does that make sense?
Yeah.
So we need to look at each one of these. Maybe we could look at them and just think about, if you rounded to the nearest 10,000, what would you get, right? So go ahead and look at the first one. If you rounded the first one to the nearest 10,000, what do you think you'd get?
I would get.
Yeah, that's the 10,000s place. That's true. It's supposed to be an arrow, I know.
And I would write.
You want to write right under here? Well done. So how did you get that? Can you tell me why you did what you did?
Because I looked at the 6. I came over here. This is a 5, and that's more than 4.
Right.
So I add 1 more to the 10,000s, and I got that.
Nice job. So you can either go up or the same, right? You can never go down. Same or up. All right, so that one worked. What do you think, yes or no? Does it look the same as that one?
Yes.
Yes. Go and circle your yes. Next one. How would this one round to the nearest 10,000?
So hold on, before you get to that next one, Riley, does that make sense to you as well?
Yeah.
All right, so you're going along with all of this. So, Rhea, how about if you ask Riley how to do the next number?
Okay.
All right? So ask Riley whatever you would like to ask her.
Riley, what does the 10,000s round to?
Riley, which number's in the 10,000s place?
I couldn't hear the number.
Oh, the next number
So
we're
we're
looking
on
at
the
is...
second one.
Yeah, the second one that you gave us, 260,987.
So you look into the 100,000s place.
100,000s, okay, we got the 2 over there, right?
Mm-hmm. And then you go next door and
Uh-huh.
see if it's 5 or more. And then if it's 5 or more, you add 1 more to the 2.
Right. Now let's look back at the question. Remember, Riley, it said that we wanted to look at the, we're going to round to the nearest 10,000, right?
Oh, okay.
That's okay. Which digit is in the 10,000s place?
Oh, it's a 6.
Good job. So there's a 6, and now you can tell us what to do from here.
So you look at the 6, and then you go next door. If it's 5 or more, you add 1 more. If it's lower than 5, you keep it the same.
Mm-hmm.
And since it is lower than 5, then you keep it the same. So the answer is 260,000.
260,000. Can you write that right under here, Rhea? 260,000 on that one. So Riley, did that one work or no?
It does.
Does that work and round to the top number that we have here, 270,000? Does that work?
Oh, no.
Ah, it doesn't work. Okay, go ahead and circle the end. That didn't work. Hey, we're halfway done. Next one, Riley, what do you think? Which digit is in the 10,000s place? 274,000? 7, yep, you got it. And the number next to it is?
4.
4. Does the 4 round the 7 up or the same?
The same.
Same, you got it. So tell Rhea what to write here.
Okay. So you are going to write 270,000.
Yep.
And then you're going to put a yes next to it.
Good job. Well done. And that one's a yes also. Last one we're going to try. Which digit in this last one, 206,636, which digit is in the 10,000s place there?
The 0.
The 0. You got it. Okay. So even if we had a gigantic number next to it, is there any way that you can make that 0 turn into a 7?
Turn into a 7?
Yeah, because at the top it says we have to round to 270,000. Is that 0 ever going to be a 7?
No.
No, probably not going to happen so much. So it doesn't really matter what that other number is. We're going to look at it anyway. But no matter what it is, it's just not going to make a 7. Let's see what this one actually does round to, okay? So Riley, what does the 6 do to the 1, or to the 0? Does it make it go up or stay the same?
It makes it go up.
Good job. So tell Rhea what to write here. You have a 2, and then what else?
You have a 2, and then a 1,
Uh-huh.
and then a 0,
Good.
and then a comma, and then a 0, and a 0.
Good. And is that a yes or a no? Does that end up being 270,000?
No.
Not so much. So we're half and half. Great job, ladies. Well done. I like what you did there.
There you go, working together on that problem. It's kind of funny that she called in with a problem that's in Rhea's book so we could
Same
actually take a
stuff.
look at it. So nice work, and Riley, congratulations. By phoning in today, you are now going to the Kern County Fair. So congratulations, hope you have a wonderful day at the fair. 636-4357 is that phone number. We do have phone tutors available until 5:30. Don't forget, if you're calling from outlying areas of Kern County as well as San Luis Obispo County, the number is toll free at 1-866-636-6284. We'll be back with more right after this. Today we're at Elk Hill School, and today we're here to
Do the math!
Elk Hill School today with Mackenzie, who's in 7th grade. How are you?
I'm good. Yeah.
All right, come on, turn around here. What's going on up there?
I have no idea.
Excellent. Tell me a little bit about anything you can tell me right now.
Okay, well, I know that these are numbers in parentheses. I think that's a -2, maybe, and that's a +3.
Perfect.
And then that's a plus sign, and this is a 4 with like a squared sign, I think, and then
Perfect.
division, and then 2.
Perfect. Everything is fine so far, so you do know what's going on. Now we just have to figure out how to do it, right?
Okay.
Okay, so this is called the order of operations, okay? There's a specific order that you need to do things. So it's sometimes kids refer to it as, please excuse my dear Aunt Sally, PEMDAS. Okay, if you haven't heard of that yet, you probably will.
I have.
You have heard
like,
of that?
Yeah, like
Okay.
once or twice.
Good. And I'm sure you're going to be doing a lot of that this year and then when you get in 8th grade as well. So we'll go ahead and do one right now, okay, because we've got a little bit of everything in here, okay? So the first thing is parentheses for the P. Do we have any parentheses?
Right here,
Okay, and what's in the parentheses?
a +3 and a -2.
Okay, so if we just read that, it's basically just 3 minus 2.
Oh, okay.
Right? So it's even simpler than what you were kind of thinking it was going to be,
Yeah.
right? So what is 3 minus 2?
1.
So put a 1 underneath it. Now just bring everything else down. Just rewrite the entire problem. Okay, so we did the parentheses. Okay, that's the first thing. We get that out of the way. We know that 3 minus 2 is 1. Everything else is just rewritten. The next thing is the E, exponents. Are there any exponents?
Is this an exponent?
That's the exponent, that's the base. So you were correct in saying that that's a squared. So it's 4 squared. Okay, do you know what 4 squared means? How do you solve that?
No, not really.
Okay. 4 squared can be written as 4 times 4.
Oh, that's 8. No, I mean that's 16.
Right, 4 plus 4. See, that's the reason we put this up here is because a lot of kids will see 4 squared and think it's 8. It's not 4 times 2, it's 4 times 4. Here's an example. If I did 4 to the 3rd power, how would I rewrite that?
4 times 3?
No.
4 times...
4. See, that's equal to, so you take the base and you write it that many times.
Oh,
So
so
what's-
it's 4 times 4 times 4.
Perfect, all right? So that's how the exponents are going to be worked.
Oh,
okay,
okay.
but we have an easy one. 4 times 4 is just 4 squared. So what is that?
That is... I just said it. 16?
There you go. So put a 16 underneath that. Bring everything else down. Okay, so we have PEMDAS, parentheses done. Okay, E exponent done. Multiply and divide are the same at the same time. You just do them from left to right if you have any. So do we have any multiplication or division?
We have division right here.
Okay. And what is that going to become?
8.
Okay, so go ahead and put that down and bring everything else down. So what do we have left?
9.
See how easy that was? Nicely done. Well, we're at Elk Hills Elementary School, and they have a school that goes from kindergarten through 8th grade, correct?
Yes.
And with us right now, Principal Mr. Tenzi. How are you today?
Good. How you doing?
Good. Thanks for having us out.
Oh, no problem. Enjoyed it.
How long have you been at Elk Hills?
This is my 7th year. Just started my 7th year here at Elk Hills.
Okay. Kids were fantastic to work with. Great students.
Yeah. We have a great little school out here. I call it my little diamond in the rough out here.
There they go. How many kids do you have out in the
We
school?
got like 175 right now.
Okay. And as we walked into the auditorium here, we saw that you have a theme going on. And what's the theme this year?
The theme this year is it's a zoo theme. It's a welcome to Elk Hills School, and to take a walk on the wild side.
There you
and
go.
so we have a zoo theme going on this year.
And the kids were pretty excited about it the first day of school, right?
Yeah. First day of school, the kids are always very excited to see what the new year is. This is our 9th year, so we're starting to get a lot of good themes going on. But the kids really anticipate the first day of school to see what the year theme's going to be.
So do you have any highlights of themes in past years that you guys have done?
Oh yeah, we've done. We've done Parents, We Shrunk the Kids. We've done 20,000 Leagues Under the Sea. We did Wild Wild West a couple of years ago.
Okay.
So we've had some really good themes.
All right. Well, you know what? Thanks for having us out once
Oh.
again with the Do the Math program. And a lot of avenues you guys probably hit, especially with science and things this year with all of the zoo thing going on.
Definitely.
Jeff, thank you once again.
Thank you very much.
And once again, a big thanks to all of the staff and students at Elk Hill School. We had a wonderful time visiting out there. Kind of cool that they do a different theme every year, and the kids get all excited about it. The first day of school, they bring the entire school into the multi-purpose room. Check that out, and they have a lot of volunteers that help put that together, and that's their theme for the year, and it works. And it's a great success out there.
It's a good deal, yeah.
A
Gotta have
couple
a
of
theme.
other schools do that as well, but I mean, the entire place was decorated with that theme, so it was pretty cool to see.
Great.
You know what? If you had to come up with a theme, let's say you had a classroom or a school and you were in charge of it, all right? Can you think of a theme? Like sometimes they go, we're going to do superheroes, or we're going to do, they did underwater life. Can you think of a theme that you might like to do or see?
Maybe jungle.
Jungle, there you go. That would be a pretty cool one. You know what? Go to your principal and say, hey, listen, I would like the school decorated like it was a jungle, and I want to see some more of that stuff, all right? Don't tell him I pushed you into it. Just bring it up to him and see what he says, all right? Are you ready to do some more work?
Yeah.
All right, head on over to the board. We're going to take a look at it. This is very cool. You have 2 math books. So we're going to go to your other math book now and take a look at what you're going to be working on coming up. So it says that you're going to estimate, and we have 3 problems here. So we'll just do them one at a time. All right, so why don't you go ahead up, right up there, 293 times 4. Now on this problem, Rhea, it says just to estimate it. It doesn't say what place value to estimate it, so it's wide open. So how would you like to go about working on this?
I would like to see what this number estimates to, write it over to the side, and
Good
then
idea.
bring the 4 over
I think
there.
that's a great idea. So how would you round or estimate that top number? What place value would you round it to?
The highest.
Good idea. All right, talk us through it, just like you did the last one, because you're really good at this.
So you go next door. If this is 5 or more, you add 1 more to this number. And it is.
It is.
So you bring it over here, 300
Well done.
times 4.
Now, what do you think about that 4? Do you want to do anything with it at all? Do you want to round it? Because if you
No.
rounded it down, we'd have nothing. If you rounded it up, might be kind of too big, huh? So we'll just stick with the 4. I think that's a good choice.
Yeah.
What are you going to do now?
Now you multiply it.
Let's do it. Sometimes you wish those things had ink, huh?
Yeah.
You jumped right to it. So I noticed, if we were doing this regular problem, right, we would do 4 times 3 and 4 times 9 and 4 times 2. But you jumped right to the end. Tell us a little bit about how you already knew it was going to be a 1 and a 2 and a couple zeros.
I already knew it was going to be 1 and 2, a couple of zeros, because these two, when you multiply it, it equals 12.
Right, and that's where the 1 and 2 came from. And then got a couple zeros there. You just bring them down or what?
I just brought them down.
You just brought them down, yeah. And if you had to go back and check it out, and you were going to multiply, 4 times 0 is 0, and 4 times 0 is 0 also. Nice job, well done. So when you go to the original problem, right, how are you going to look at this answer and compare it to the other one? Is the original problem going to be bigger than 1,200? Is it going to be smaller than 1,200? Do you really care about if it's bigger or smaller?
No.
If this answer that you got on the problem that we're going to do in a minute, if this answer ended up being 17,000, you think that might be a problem?
Yes.
Yeah, too big, huh? So it wouldn't be very close. So we would like it to be close to your estimate.
Yes.
You want to work out the real thing?
Yeah.
All right, let's see what you got. So 4 times 3 is 12, right? You put down the 2. Where's the 1 go?
Up here.
Good call.
And then you do these two.
And your next problem is 4 times 9, right? Okay.
And then that equals 30. And then you add 1 to
Right.
the 32.
Yeah, so 36, right?
Yeah.
And then add
Add
one
one.
more?
And you 37.
37. So what's going to go down on the bottom, and what's
This.
going to be carried?
The 7.
Nice job. Yep. Put the 7 there, and then the 3 is going to go way up there. Now, so far, we can't compare it to your rounded answer, right? Because your rounded answer has 2 zeros in it, and this one has a 7 and a 2. So we don't even know if we're close yet, but this is going to be the telltale part right here. Let's see what happens. So your last multiplication is what two numbers are you multiplying?
3 and 2.
Almost. Remember the 3 is going to be added? In fact, I'll go ahead and
yeah.
put a little plus sign here that we're going to add that in at the end. So what numbers are you multiplying?
2
Uh-huh.
and the 4.
Good job. And what's that?
8.
8. And then you're going to add in your 3?
And that equals 11.
Good job. So put down your 11 there. Good work. So tell us what the actual answer is. Can you say it in words, please?
1,000, 1,172.
Good job. And what's the estimated answer?
1,200.
Are they close?
1,200.
1,200. Are they close?
Yeah.
They're pretty close. How close are they? Let's look at the thousands place. Is the thousands place the same?
Yes.
Yep. How about the hundreds place? Is that the same?
No.
Not quite, but pretty darn close, right? Can you tell us, we don't have to do it if you don't want to, but I'm interested to hear from you, how could you tell how close those two numbers are? Like how far apart they are? How could you do that? What would be a kind of a math problem you could do to figure out how close those two numbers actually are to each other?
Subtract this from that.
That's it. You could totally subtract them and you would see exactly how close they are. Great job. I really like how you worked out that problem. That was awesome. So we move on to the next one. I hear we got some dollar signs over there. Is that right?
Yeah, you know what? We're going to do one more right now. So go ahead and erase that.
Ready? Hooray.
All right. And Rhea, what I'll do is I'll have you move further over towards the center of the board. There you go. Because I've got a little bonus to add on this problem for you later on. All right. So let's go ahead and write down the problem first. $416. So 416 times 6.
Great job. Okay.
And it says to estimate again.
Better do some estimation.
Bring this over.
So you're going to estimate the top number first? Great idea. And which place are you rounding to?
The highest.
The hundreds again, okay.
Okay.
And talk us through this. You have a 4. Is that 1 going to help your 4 go up or stay the same?
Stay the same.
Stay the same. Good deal. And what happens to the 1 and the 6? They become?
A 0.
0. You got it. And then we have the choice at the bottom again. You going to do anything with the 6?
No.
Nah, just leave it. Sounds good. Okay, now one thing when I'm working on a problem like this, so far everything you've done is wonderful. But sometimes you get through all the numbers, and at the end of the problem, you forget that it had a dollar sign. So here's what I want you to do. Before you even do any numbers at all, can you put a dollar sign here on the real answer and a dollar sign there on the estimated answer so that we don't forget to put the dollar sign and we'll know that this problem involves money? There you go. It's a good reminder. Then you don't have to worry about putting it at the end. Okay, walk us through the estimated problem there. 400 times 6. So you got a 2 and a 4 and a 0 and a 0. And where the heck did they come from?
You got the 2 and a 4 because when you times 4 times 6, it equals the 24, and then you just bring the 2 zeros down.
Well done. I like it. Okay, let's go to the real thing. It's got to be really close to 24,000, right? Is that number over there, 24,000?
Yes.
No. Check it again. What is that number?
2,400.
2,400. So we're hoping that the real answer is close to 2,400. All right, let's see what we got. So 6 times 6?
36.
36. You put down the 6, carrying the 3, if it'll let you write it.
And then you times these two.
Yep, 6 times 1. Nice job.
It's 6, and then add the 3, 9.
9. And nothing to carry on that one, huh? And the last one?
4 times 6.
Yep.
To equal 24.
Okay, let's see how close they are. Are you ready? Is the thousands place the same?
Yes.
It is. Is the hundreds place the same?
It is.
It is. Is the tens place the same?
No.
Not quite. And if you had to figure out how close they were, you told me you could subtract them, right? And the only differences are these numbers right here. So can you, in your head, we're going to put you on the spot here. We'll see if you can do it. In your head, can you tell me how different these are? How far apart are they?
96.
96. I circled it for you. Maybe I gave that one away. So that one worked out pretty well. Nice job. Well done.
All right, over on the far left, Scott, go ahead and write this down. $4.16 times 6. Now, Rhea, go ahead and do that problem. Now that we've put a decimal in there for you and see what happens.
Should we estimate that one as well?
No, we'll just go ahead and do it.
Go ahead and do it. So Rhea, before you start, can you tell me a little bit about this? You did a problem that looked awfully similar over there. This one looks pretty darn close, but you put a decimal in there. What is that going to do to the answer just ahead of time so we know what to expect?
With the decimal point.
You're going to have some decimals in your answer too, right? And also, tell us about your answer. Your answer over there was in dollars. Is your answer over here going to be in dollars?
Yes.
Okay, put that dollar sign in there for us. There you go. Now, do you want to work out all this problem again?
No.
Oh, no, I don't blame you there. Look back over there. Do you see how all the numbers are the same? Everything's the same, right? So the answer to this problem is going to have the same numbers as the answer to that problem, right? Can you write down those numbers? And then we can talk about that decimal place. Yeah, and put the same numbers there too. So 36 carry the 3. 6 times 1 is 6 plus 3 is 9. And then the last part is 6 times 4, right? Good deal. Now, the other one you put a comma in, right? But that's because we didn't have a decimal place. Where does that decimal place go in your answer?
Right.
How'd you get that? How'd you know?
I knew because the decimal point is in the same place as the comma.
Ah, okay. Well, your comma went between the 2 and the 4, and you put your decimal place between the 4 and the 9. So I like that deal. We're going to make this a little bit more of a dot if we can, and I'll do that with red so we know where it is. But look at the very top number. The top number says $4.16, right? How many decimal places are in that number?
1.
You see you have your 1 here, that's right. And then 1 more, right? Would you agree with that? So we have 2 decimal places, right? 2 of them on the right. So this number has 2 decimals on the right-hand side. When you go to do this number, we want to have 2 decimals on the right-hand side. So we're going to go backwards here. And that's why that decimal ended up in the same place. Tell us how much money this is.
$24.96.
Gotcha. And how much money did you have in the problem before?
$2,496.
And which one would you rather have? That one. That's exactly right. And why? Because the decimal place makes a huge difference, right? It makes a really big difference. So if you happen to misplace the decimal, it makes a lot of difference in the amount of money that you have.
Yeah.
I guess I'll go ahead and take that one if you got the other one. Nice work. Well done.
There you go. Just wanted to get the importance of where a decimal point goes and why it is important. Right now, we're going to go to the phones, and we have Katrina on the line. Katrina, how are you today? Hello, Katrina. I think we've got Katrina coming in just a moment. Katrina is a 7th grade student at Tevis. And Katrina, how are you today?
I'm good.
And you're in 7th grade, correct?
Correct.
All right. Have you phoned in to do the math in the past?
Yes.
All right. I thought you sounded a little familiar. So, Katrina, as soon as you're ready, let's hear the math problem that you're working on. And Rhea, you can come on over here now. We're not going to make you do that 7th grade work. You can watch with me over here.
The instructions for the problem say, determine whether the relationship is a proportional relationship. If so, write an equation for the relationship and tell what each of your variables represents. If the relationship is not proportional, explain. Ty takes 1 hour to read 35 pages, 2 hours to read 70 pages, and 3 hours to read 105 pages.
Okay, so we have 1 hour for 35 pages and 2 hours for 70 pages, and the last one was 3 hours for how many pages?
105 pages.
105 pages. Okay. And we have to figure out, it sounds to me, if this is proportional or not, right?
Correct.
Okay. So tell me a little bit, Katrina, about proportions. What do you know about proportions?
Not much. The teacher didn't really explain.
If you had to write a proportion somewhere on your paper or on your homework or somewhere on a test, what kind of form would that number take? Would you put it in a decimal? Would you put it in a whole number? Would you put it as a subtraction problem? Would you put it as a fraction? What would be your choice?
Fraction.
A fraction. Okay, so let's have some fractions here. So we have one fraction. Let's look at the very first thing you told me. You said 1 hour and 35 pages. So we have two things we're talking about here. We're talking about hours and we're talking about pages. Which one would you like to put on top?
Pages.
Pages, okay. So 35 pages on the top and hours on the bottom, is that okay?
Yeah.
Okay. And 1 hour. And then we want to know if this is proportional. So here's the deal. We're not going to look at any other of the numbers yet. We're going to go ahead and see if we can work with just these numbers here. If you had 1 hour and you read 35 pages, what would happen if you went at the same exact pace for the next hour, right? After 2 hours, the first hour you do 35 pages, and the next hour you do 35 pages. And so what would happen? How many total pages would you have read after 2 hours?
70.
70, you got it. So we're not even looking at that stuff over there, but so far, it's looking pretty darn good. That's exactly what you told me, 2 hours and 70 pages. So let's look at one more here. We have one more. It says we're going to go for 3 hours now. And we want to go ahead and see what's going to happen for 3 hours, even without figuring out if it's the number that you gave me. So 3 hours on the bottom. We'll take that same 70 you gave me, and remember, every single hour, you go back to the beginning information you gave me, you said every single hour we're going to read 35 pages, so we'll put another 35 in there. Can you add those two together for me? 70 plus 35?
105.
105. Good guess, just in case you didn't see it, it's right there. So look at these proportions here. This worked out wonderfully well because the numbers that you gave me are exactly the same as the numbers that were at the beginning of the problem. So, question for you, are these three things that you told me, are they proportional?
Yes.
They are. They all work out nicely. And we don't have to necessarily do the problem, but I'm curious to know if you had to go 1 more hour, right? If you had to go to 4 hours, how would you get to the next number of pages on the top?
Multiply 35 times 4.
Wonderful choice. 35 times 4. And if you had to go 17 hours, what would you do and how many pages would that be? 35?
Times 17.
Times 17, that's it. So however many hours you have, you would multiply it times that number of hours and you'd get your final total. Well done. I'm very impressed with your work there.
Great problem right there, Katrina. And because you phoned in today, we were able to do that one on air. You automatically have received yourself a ticket to the Kern County Fair. A 1-to-1.
Yeah?
Right there, that ratio.
That worked out well.
Anyway, hey, we do have phone tutors available until 5:30. 636-4357 is that phone number. Don't forget, phone number is also toll free in outlying areas of Kern County, 1-866-636-6284. We'll take a look under the camera. Here's an example of the stickers that the County Superintendent of Schools office has sent out to all of the different schools in Kern County. And if your school has not received any of these yet, or the binder dividers, or the posters, or the variety of other things that are passed out to every single school, simply let us know. The phone numbers are at the bottom of your screen. Just call us up, say, hey, listen, I know we've seen these stickers in the past, and I put it on my binder last year, but I've got a new binder, and we don't have our stickers yet for whatever reason. So all you need to do is simply give us a call. We'll send out as many stickers, binder dividers, posters as you would like to your schools. Also, last week and this week, we were fortunate enough to work with some students a couple of weeks ago from Elk Hills School.
Right.
And we have an opportunity to go out to a bunch of different schools throughout the year and work with some students there. And then we can put those kids on the Do the Math program. If you would like Do the Math to come out to your school, all you have to do is talk to your principal, your math teacher, see if you guys can work it out. Give us a call on a Tuesday or Wednesday, and we'll see if we can get you in there. We are waiting for another call. I think, do we have Thomas ready right now, or Eric? I think we have Thomas ready now. All right, we do have Thomas ready. Thomas, how are you today?
Good.
What grade are you in?
5th.
All right, as soon as you're ready, let's hear that math problem.
I'm ready.
Go.
Wait. What's the problem?
You read the problem. Okay, so the way I've got it here, what you've told them is you have 26 employees, and and $410 per week.
Yeah.
And it says after 1 week, he has $162.
Okay, yeah, because he paid them all.
Right, so you don't have this on something, I take it?
I have some paper.
Okay.
Back paper.
All right, so you're able to see the program, right? Oh, no, you can't see it either. All right, so here we go. This is going to make it fun. All right. So we've got 26 employees.
Yeah.
$410 per week.
Yeah.
After 1 week, you have $162. So you have $162 after 1 week.
Yeah.
Okay, now was there a problem you needed to do here? What do you need to solve on this problem? Or do you want me to come up with something for you?
I need to find. I think I need to find out how to divide 162 evenly.
So you want to take, keep going.
Wait. Yeah. I have to figure out how to divide 26 evenly with 410.
So you've got 26 employees and you need to get that $410 out to the 26 employees, is that it?
Yep.
All right, let's go ahead and do that.
Sounds good. So what kind of a problem are we looking at there, Thomas? You said we had to get this money out to each of the employees. Is this add, subtract, multiply, or divide?
Division.
Division. Okay, so I'm going to set it up for you. You tell me which number goes on the outside and which number goes on the inside.
26 outside
Okay.
and 410 on inside.
Well done. Okay, here's your first step. How are you going to go about dividing this? 26 goes into 4. Does it go into 4 at all?
No, so I have to move over to 41.
Good idea. We'll look at 41. That's right. How many times does 26 go into 41?
Once.
Once. Let's do it. So I'm going to put a 1 up top, right over top of the other one. And 1 times 26, what do you got there?
41 minus 26 equals,
Got to do a little borrowing from that 4, huh? So we borrow from the
14?
4, 11. Go ahead.
15.
15. Good job. And I'm going to bring the 0 down. Would you agree with me?
Yeah.
Okay, now we have a really interesting problem. How many times does 26 go into 150? Let's do a little estimating in our heads. How about that?
Here's what we're going to do, Scott.
Okay.
This is going to get a little involved going on here. This is going to be 15.769.
Okay.
And there's going to be a lot of other numbers after that, but we're going to cut to the chase here.
So Thomas, we love calculators, and that's how we got that number for you. We saved you a little bit of time. So this is the number here, right? And this is dollars because it said we needed to put, we had $410, right? So $15.769. What should we do with that number? Should we do some rounding?
Yeah, I guess we could try rounding.
Good idea. Let's round this one to the nearest cent. Tell me which digit is in the cents position, or the in this case, the hundredths position.
For 26?
Yep, the 6, that's right. And the number next to it is the 9. Is the 9 going to round the 6 up, or is it going to stay the same?
Up.
Up, that's right. So I'm going to write your new number over here. And we're going to have $15, that's going to stay the same. And we're going to have the 7 is going to stay the same, and you told me the 6 is going to round up to a 7. So $15.77.
And Thomas, that's what we're going to leave you with right now, $15.77. And then if you think of there's something else you need to do with that problem, give us a call back because we do have phone tutors available until 5:30, okay? All right, great deal. And you know what? You are going to the Kern County Fair as well. And you know what? I think we've got about 3 more minutes, Scott, for you to work with Eric right now. So we're going to go to the phones with Eric, our last phone caller of the day. How are you this afternoon? What grade are you in? Okay, so you can't see this right now. So let's go ahead and hear what you're working on.
Okay, I'm going on Google.
Okay. Read the problem.
Okay, the problem is determine whatever the relationship between the two quantities shown in each table are proportional. By graphing on the coordinate plane, explain your reasoning.
Okay, so Scott, here's what we're going to do. You're going to come right over here and work on this.
Okay.
Because I've got it already written out.
Oh, great.
And we'll just move it up and down a little bit, but I think what we can do is we can basically get this right there.
Oh, wonderful.
So let's go ahead, because you've got about 2.5 minutes to work on this problem.
Okay. Gotcha. So we have this graph here, right? You said it was on a coordinate plane.
Yes.
And you said that we have a chart here. It looks like 1 week is 125, and 2 weeks is 150, and 3 weeks is 175. Are those numbers corresponding with what you have?
Yes.
And then it said we want to figure out if it's proportional. Did you see that last problem we did with proportions? Proportions were in fractions, right?
Yes.
So we want to see if that's going to happen with this problem here. I really like the fact that we have a graph. What kind of shape do all the dots make when you connect them on this graph?
They
Look at your graph. What kind of shape are all the dots in?
It's a square.
Almost. There's a whole bunch of squares on the page, right? But if you look at that graph that you have and you connect the dots, do you see it's a completely straight line?
Yeah, wait.
So that's kind of nice. It's nice to have a completely straight line if you want to look for proportionality. Now next to that, I'm going to go ahead and start to write some of these fractions. We're going to keep the weeks on top and the amount on the bottom. 2 and 150, 3 and 175. So
I'll give you guys 1 minute to wrap it up.
We can do this. Here we go. Ready? If you go from 1 to 2, how far do you go up? What are you adding?
We're adding, wait.
From 1 to 2.
1.
1, that's it. How about 2 to 3?
You're adding 3.
Adding 1, almost. Plus 1, plus 1. Do you see how we're going up 1 every time?
Yes.
How about look on the bottom? From 125 to 150, how much are you going up?
125 to
25 to 150? We're adding 25. Do you see that?
Yes.
And then what about 150 to 175? How much are you going up there? Think about $1.50 and $1.75. How much did you go up? 25 is what I thought I heard you say. So if you continue to go up the same on the top and the same on the bottom, then we do have a proportional relationship. And the best way to describe that is the fact that we had a straight line on the top. So it's nice to have a graph on that problem. Thank you so much for calling in.
Nicely done, Eric. Congratulations. You as well are going to the Kern County Fair. And Rhea, since you did excellent work today, you are through working, except you need to figure out who's going to the Condors from all of the students that phoned in today. So pull one of those cards out, and who is that?
Eric.
That is Eric, student from Chipman right there. So congratulations, going to the Condors as well. Hey, we have phone tutors available until 5:30, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.